Hey everyone, today we're diving into the amazing protective systems that keep your brain and spinal cord safe and sound. Think of your CNS as a super important VIP that needs serious security. We'll cover the major players: bone, meninges, cerebrospinal fluid, CSF, and the amazing blood brain barrier, BBB. These elements work together to shield your brain and spinal cord from harm. Key takeaways: your CNS needs multiple layers of protection. Bone provides the outer shield, while meninges, CSF, and BBB add inner defenses. Together, they work to keep your brain and spinal cord safe. The bony armor is the first line of defense for your central nervous system. Let's explore how the skull and vertebrae protect the brain and spinal cord from physical trauma. The skull acts like a helmet, encasing the brain completely. It consists of cranial vault bones like the frontal, parietal, occipital, temporal, sphenoid, and ethmoid bones, plus facial bones such as the nasal, lacrimal, zygomatic, maxilla, and mandible. This hard bony structure protects against impacts from falls or blows. As shown here, the skull provides a rigid barrier that absorbs and distributes the force of impacts, preventing direct damage to the delicate brain tissue beneath the meninges. This view shows how the skull's interior perfectly molds to the brain's shape, providing cushioning space and protecting against rotational forces that could cause injury. Now, turning to the spinal cord, the vertebrae form a protective column along its length. The spine is divided into regions: cervical in the neck, thoracic in the chest, lumbar in the lower back, plus the sacrum and coccyx. Each vertebra has a hole for the spinal cord and provides structural support. These different views highlight how the vertebrae stack up to form a flexible yet strong tunnel for the spinal cord. The bony structure prevents compression from above or impacts from the sides, much like a spinal column in engineering. Remember, the bony armor of the skull and vertebrae is your CNS's first line of defense, offering crucial mechanical protection against everyday impacts and injuries. Next, we have the meninges, three membranes that wrap around your brain and spinal cord like protective bubble wrap. These layers provide cushioning and help maintain the structural integrity of your central nervous system. Here you can see the three meninges surrounding the brain: the dura mater, arachnoid mater, and pia mater. These membranes create protective spaces and barriers. The dura mater is the toughest outer layer, like a tough leather jacket protecting your brain from bumps and knocks. It attaches directly to the skull and provides mechanical strength. The arachnoid mater is the middle layer with a spider web-like structure. It contains cerebrospinal fluid and helps cushion the brain from sudden movements. The pia mater is the delicate inner layer that clings tightly to the brain's surface, following every fold and groove. It's very thin but essential for protection. These same three layers also protect your spinal cord, wrapping around it just as they do the brain. To remember, the dura mater provides tough outer protection. The arachnoid mater offers web-like cushioning with cerebrospinal fluid. The pia mater is the delicate inner layer, and together they act like bubble wrap for your brain and spinal cord. Let's talk about cerebrospinal fluid, or CSF for short. This clear, colorless fluid is like a protective waterbed for your brain and spinal cord. CSF is produced by special cells called ependymal cells, located in structures called the choroid plexus within the brain's ventricles. These cells make about 500 milliliters of CSF every day. That's like filling 2 soda bottles. Once produced, CSF doesn't just sit there. It circulates through a system of spaces called ventricles inside the brain, then flows around the brain and spinal cord in the subarachnoid space before being absorbed back into the bloodstream. CSF serves several important functions. First, it's a shock absorber. When you bump your head or experience sudden movements, the CSF acts like a waterbed, cushioning the brain and preventing it from slamming against the skull. CSF also transports nutrients to brain cells and carries away waste products. Think of it as the brain's delivery and garbage service, keeping everything running smoothly. Here's an example. When you're running and suddenly stop, your brain wants to keep moving forward due to momentum. But CSF provides that cushioning effect, preventing injury. To wrap up, remember that cerebrospinal fluid is your brain's built-in protection system. It's produced continuously, circulates to provide cushioning and nutrient delivery, and helps keep your central nervous system safe and healthy. The blood-brain barrier, or BBB for short, acts like a highly selective gatekeeper for your brain. It protects the central nervous system from harmful substances circulating in your blood while allowing essential nutrients and gases to pass through. The BBB is formed by tight junctions between the cells that line the brain's blood vessels. These tight connections create a barrier that prevents most substances from leaking out of the bloodstream into the brain tissue. This selective barrier allows essential nutrients like glucose and oxygen to cross through specialized transport mechanisms. Gases like oxygen and carbon dioxide can diffuse freely, and some lipid-soluble molecules can pass directly through the cell membranes. At the same time, the BBB blocks harmful substances like pathogens, toxins, and many drugs from entering the brain. This protection helps maintain a stable environment for delicate brain cells. However, there are a few important exceptions where the blood-brain barrier is absent or more permeable. These areas allow the brain to monitor hormone levels in the blood and detect potential toxins. For example, the hypothalamus and pituitary gland lack a complete BBB, allowing them to sense hormone levels and release appropriate hormones into the bloodstream. The area postrema, often called the vomit center, also lacks this barrier to detect toxins and trigger protective responses like nausea. Key takeaways. The blood-brain barrier protects your brain by being highly selective about what enters. It allows nutrients and gases while blocking harmful substances, but has strategic gaps in areas that need to monitor the body's internal environment. Let's explore how CNS protections work in real life. Imagine you're biking without a helmet and hit a bump that causes your head to jolt. The skull acts as the first line of defense, absorbing much of the impact to protect the delicate brain tissue inside. Without proper protection, this force could cause a concussion or worse. But with a helmet, the impact is distributed more evenly. The meninges underneath provide additional cushioning between the skull and brain, while cerebrospinal fluid acts as a shock absorber, helping to distribute the force and minimize damage to neurons. Now consider another scenario. You accidentally ingest a harmful substance. The blood-brain barrier serves as a selective gatekeeper, preventing most toxins and pathogens from crossing into the brain tissue. The BBB's tight junctions and specialized cells only allow essential nutrients like oxygen and glucose through, while blocking dangerous molecules. This protection prevents inflammation and damage that could lead to conditions like encephalitis or other neurological issues. Key takeaways. Your CNS has multiple layers of protection working together, from the hard skull to the selective blood-brain barrier. Always wear helmets during activities with impact risk, and be mindful of substances you consume. These protections help maintain brain health and prevent serious damage. Sometimes, despite all these protective layers, things can go wrong. Let's look at what happens when the CNS's defenses fail, starting with strokes. Next is hydrocephalus, which happens when cerebrospinal fluid builds up, putting pressure on the brain. Finally, intracranial hemorrhages are bleeds within the skull that can damage brain tissue. These conditions show just how important all those protective mechanisms are for keeping your brain healthy. Without them, even small disruptions can have devastating effects.